suppose that the Sharp Company sells sets of kitchen knives. Value set has 2 paring knives and a medium knife. A regular set has 2 paring knives, a medium knife, and a chef's knife. Deluxe set has 3 paring knives, a medium knife, and a chef's knife. Profit is $30 on a value set, $40 on a regular, and $60 on a deluxe. We have given the limitations, the numbers of knives of each type that the factory has on hand. We're going to assume that all the sets will be sold, and then we want to figure out how many of each type should be created in order to maximize profit. And we want to find out what that maximum profit is. So the first thing we want to do is define our variables, figure out what they're going to represent. You could use x1, x2, x3, or you could use x, y, and z. I think that's what I will do. Let's let x be, okay, it says how many of each type. So what is it talking about? Those are sets of knives. What types of sets of knives do we have? We have value sets, we have deluxe sets, and regular sets. Now I'm not going to say x equals value sets because remember x should represent a number. So be sure you are careful with this. The x is not equal to value sets, but the number of value sets. And then let's let y be the number of regular sets. And let's let z be the number of deluxe sets. Now we want to write our model. First of all, are we maximizing or minimizing? We are maximizing, and we are maximizing profit. And you may want to make a table for this one. Let's make a table for this one. Value, regular, deluxe, and then we're going to have paring knives, medium knives, chef's knives. It sometimes helps to do that just to summarize the information and get it into a more compact form. Value knife, we have 2 paring and a medium, and no chef's knives. The regular, we have 2 paring, a medium, and a chef's knife. And the deluxe, we have 3 paring, a medium, and a chef's. And then we also have some profit for each of these. Okay, so $30, $40 on the regulars, and $60 on a deluxe set. These are some expensive knives, apparently. And then the amounts that we have on hand. Keep in mind here that these are maximums because we cannot make sets with knives that we do not have on hand. In other words, we only have 800 paring knives on hand. Therefore, we cannot use any more than 800. That 800 is the maximum number of knives that we can put into our sets. We have 400 medium knives, and we have 200 chef's knives. So we can use all this to write down our model. We're going to maximize our profit. So our profit from the value sets will be 30 times the number of value sets, so 30x. Our profit from the regular sets will be 40 times the number of those, so 40y. And the deluxe set, I have 60 for each times the number of deluxe sets, so 60z. Subject to, and these will be our constraints. Okay, we know we can't have any more than 800 paring knives put together in our set. So less than or equal to 800. How many paring knives do we need? Well, 2 times the number of value sets, so 2x. Then 2 times the number of regular sets, so 2y. And then 3 times the number of deluxe sets, so 3z. Now we move to our medium knives. 1x, 1 times the number of value sets, plus 1 times the number of regular sets, plus 1 times the number of deluxe sets, cannot exceed 400. Chef's knives, 0x, so we don't have any of those in the value sets, but we do have 1 times the number of regular sets plus 1 times the number of deluxe sets, and we only have 200 of those on hand. It does not make sense to include to create negative numbers of these sets, so that means x, y, and z have to be non-negative. So we're going to use this to write our initial system. We're going to put in the slack variables. So that first constraint, I'll have 2x plus 2y plus 3z plus s1, that's my slack variable, is equal to 800. Move to my second constraint, x plus y plus z plus, I'll add s2, slack variable number 2, is equal to 400. Third constraint, y plus z plus my third slack variable is equal to 200. And then I go back to my objective function. I move everything to the left side by subtracting. So we end up with negative 30x1. Sorry, that should say x. Negative 30x. Negative 40y. Negative 60z plus p is equal to 0. And then, of course, x, y, z, and all my slack variables have to be non-negative. Keep in mind that here our slack variables actually represent something. S1 represents the number of paring knives that are left over in the factory that didn't get put into sets. S2 is the number of medium knives that are left in the factory and didn't get put into sets. And S3 is the number of leftover chef knives that didn't make it into a set. Let's write our initial simplex tableau. So for my x's, I'll have 2, 1, 0x in that third constraint, and then negative 30. For my y's, I have 2, 1, 1, negative 40. For my z's, 3, 1, 1, negative 60. S1, 1, 0, 0, 0. S2, 0, 1, 0, 0. S3, 0, 0, 1 in the third row. And for my p, everything is 0 except for the last row. And then my coefficients on my right-hand side, 800, 400, 200, and 0. This is my initial simplex tableau. Okay, and we note that this is indeed a standard maximization problem, which makes it okay to do simplex on it. We look for the most negative. So that is this negative 60. So we use that as our pivot column. Then we go to the right side and calculate our quotients. So first we have 800 over 3, which is 266.7. 400 over 1, which is 400. and then 200 over 1, which is 200. And that will be our smallest. So there is our pivot row, and therefore here is my pivot element. So what I will do is I will do row operations to get a 1 in that slot, zeros elsewhere in that column. I'm going to do mine using a graphing calculator program or computer program. And so I will skip doing the row operations by hand and just write the new tableau. You should do this along with me to make sure that you get the same answer when you do your pivot. Okay, so when I do that pivot, I have for my first row 2, -1, 0, 1, 0, -3, 0 for P, and then 200. Second row, I have 1, 0, 0, 0, 1, -1, 0, 200 again. Third row, 0, 1, 1, 0, 0, 1, 0, 200, and then last, -30, 20, 0, 0, 0, 61, and 12,000. Okay, so now we are ready to pivot again. Why do we need to? Because we still have at least one negative on the bottom row. Here it is. This is the most negative, so that will be our pivot column. So then we go to the right, we calculate our quotients. So my 200 over 2 gives me 100. 200 over 1 gives me 200. The last one, I cannot do it because I have a 0 in my pivot column, and I cannot divide by 0, of course, in any circumstance. If I had a negative there, I would not compute a quotient either. We only compute quotients for positive numbers in the pivot column. So now we need to figure out which of these is smallest. Looks like this one. Okay, so that puts me at using the first row for my pivot row. And so this first row, first column entry becomes my pivot element. And so now I do another pivot. So we're going to get a 1 in that entry, zeros elsewhere in the column. When we do it, this is what we get. That's my first row. Second row, I have 0, 1/2, 0, -1/2, 1, 1/2, 0, 100. Third row, 0, 1, 1, 0, 0, 1, then 0, then 200, And the last row, 0, 5, 0, 15, 0, 15, 1, and 15,000. Okay, remember this bottom row, which we can think of separating out. You don't have to, but remember that represents your objective function. That means, and when we look at that bottom row, we look to see if there are any more negatives. In this case, there are not. So that tells us that we have the optimal solution. And all we need to do is write it down. Okay, so first of all, let's make sure we notice, and you certainly don't have to write this every time, but I'm writing it so that I can make sure that you understand the non-basic variables. These are the ones with the junk in the column that are getting set equal to 0. Okay, these are y, so my y is 0. My S1 is 0. And my S3 is 0. Notice those are the columns that do not look like they are columns out of an identity matrix. Okay, our basic variables, these are the ones where we have ones and zeros in that column. For these, we get the values by looking at the right-hand side. So that means that I have x equals 100, z is equal to 200, and my p is equal to 15,000. Okay, so now I have values for all the variables. We need to interpret these according to the original problem. Remember, x, y, and z represented the numbers of value sets, regular sets, and deluxe sets of knives. And so here, this means that we should create or package 100 sets, 100 value sets Okay, y is 0, so that means we should make no regular sets at all. Remember, y stood for the number of regular sets, because y is 0, and z represented the number of deluxe sets, so we've got 200 of those. And our maximum profit is $15,000. Okay, it's important to point out what the S1, S2, and S3 represent. And in fact, I forgot to write S2 down when we did our basic variable. Sorry about that. My S2 is equal to 100. Okay, so remember S1 came from the first constraint, which had to do with the number of paring knives left that were available in the factory. S1 equals 0 means that we used up the entire supply of 800 paring knives. S2 equals 100. That represented the number of medium knives that were in the factory, so that means we have 100 leftover medium knives that didn't make it into a set. S3 equals 0. That one was from the chef's knives. That means we used up all of the chef's knives that were in the factory. So don't be surprised if you end up with some slack variables that are non-zero. And it's certainly possible some of your decision variables could be 0. That would not be at all surprising, and that's the way it turned out in this case.